We will discuss the topic vibration absorber in vibration engineering. Vibration absorber in which we give the external excitation of the body. In this, it becomes that necessary to eliminate them by coupling some vibrating system to it. Vibrating system is known as vibration absorber or dynamic vibration absorber. In such cases, the excitation frequency is nearly equal to the natural frequency of the structure. The mass which is excited can have zero amplitude of vibration. Spring mass system is coupled to its vibration, vibrates freely, and the absorber that are used to control structure resonance. For the resonatic condition or the resonatic frequency, that is omega is equal to omega n, and that is equal to in root k1 by m of the system. A spring mass dashboard system is shown in the diagram. First is the spring mass simple dashboard system, and second is the system with absorber. In the first cases, the displacement is x1, and in second cases, the displacement will be x1 and x2. For both cases, the frequency you find the omega and omega 1 and omega 2. Omega 1 is equal to root k1 by m1, and frequency in case of absorber, that is omega is equal to omega 2 is equal to k2 by m2 in root. The displacement will be same in the system, then k1 by m1 is equal to k2 by m2, and this is calculated by the equation that is explained earlier, that is equal to m1 x1 double dot plus k1 x1 plus k2 x1 minus x2, or f sin omega t. For the second system, or the in case of absorber, that is equal to m2 x2 double dot plus k2 x2 minus x1 is equal to 0. By assuming the value of x1 x2, we have the value of x1 is equal to a1 sin omega t, and x2 is equal to a2 sin omega t. x1 double dot x1 dot, or the velocity vector displacement vector, that is given by x1 double dot acceleration vector, x2 double dot is also acceleration vector, that is equal to minus omega square a2 sin omega t. By substituting this value in above equation, that we find that the k1 plus k2 minus m1 omega square a1 minus k2 a2 is equal to f, and the next minus k2 a1 plus k2 minus m2 omega square a2 is equal to 0. We have the two equations. By solving this equation by the matrix method, then we find the value of a1 and a2. If the mass and spring constant of absorber system are elected in such a way that equation omega is equal to root k2 by m2 is satisfied, it becomes a dynamic absorber system. That is, assume that the amplitude A is equal to f by k1, that is static deflection or zero frequency deflection. Omega 1 and omega 2 is equal to root k1 by m1 and k2 by m2, and the mass ratio is m2 by m1. For this condition, the value of amplitude will be the k2 by k1 minus m2 into omega square by k2 f by k1 m1 into m2 in the upon m1 m2 omega 4 k1 k2 minus m1 k2 upon k1 into k2 plus m2 k1 plus k2 upon k1 into k2, the whole multiply into omega square plus k1 k2 upon k1 k1 upon k1 into k2, that is equal to the a1 and ast, that is a standard amplitude or static amplitude. Then we get here from a2 and a2 upon a standard or a static. A2 upon a static is equal to the minus omega 1 square upon mu omega 2 square is equal to minus k1 upon mu m1 dot m2 k2. From where a2 is equal to minus f by k1 into k1 by mu m1 into m2 by k2 is equal to minus f mu upon mu k2 is equal to minus f k2, from where the value of f is equal to minus a2 into k2. A2 K2 is the spring force of absorber system, and it is equal and opposite to the exciting force when the main system is stationary, means the value of amplitude A1 is equal to 0. When mass m1 is moving downwards, mass m2 moves upwards, the energy of the main system is absorbed by the absorber system, which is sometimes known as auxiliary system. When the exciting force is constant, the amplitude of the auxiliary system is inversely proportional to its spring constant k2, as can be seen in the equation 5.9.12. This equation is useful in the design of absorber. Two resonant frequencies can be determined by putting omega 1 is equal to omega 2 in the denominators of the equation, that is 9.10 and the 5.9.11, and equating them to 0, that is equal to omega by omega 2 whole power 4 minus 2 plus mu into omega by omega 2 in the whole power whole square plus 1 is equal to 0, or we can say that omega by omega 2 whole square plus 1 is equal to 1 plus mu by 2 plus minus in root mu plus mu square by 4. On the basis of above equation, a plot has been shown in the figure, that is, we can see clearly that is show the value of omega by omega 2 and the mu. This figure shows the effect of mass ratio on the natural frequencies of system. For each mass ratio, there are two natural frequencies which are above and below the natural frequency of the main system. For the example, the mu is 0.25 responses occur frequency 0.78 and 1.28 times that of the main system, but when mass ratio is 0.5, response at the resonating condition will occur at a frequency 0.707 and 1.414 times that the main system. So it is clear that for small value of mass ratio, the two values of frequency are found closer to unity, that is shown in the diagram, from where the value of A1 and AST is equal to this, and omega by omega 2 whole square is equal to 1.1 plus minus 0.458. Thank you.